This next instruction we're going to write in together. So we just finished with this unconditional jump, and now we have to do our add here. So we're going to copy this command and put it right here. This is our instruction. Now, what is our address? We know we are at 10E here. So inside of here, we are going to paste in our 10E. Our operation is an add. Our destination is AX. And then our source is D of X. So we have add AX DX. So DX is going to be added to our A of X, and that result is going to be stored in our A of X. Now, what is our instruction formatting? We can go to the hand assembly instruction. We're going to look at our add, and we have an AX and a DX. And so for this one, we are adding a register to register, so it's going to be something like how we have up here. We'll write this down here, reg. I'll just do reg1 to reg2, but we don't know if it's reg1 to reg2 or reg2 to reg1 yet. And so I'm just going to try this out. We know that our W is going to equal 1, so we'll write that in a second. But we're going to have 4 zeros here, 3 zeros, our W, and then our 11, reg1, and then reg2. So when we look at this, when we go to the binary format, we are going to see that all we have in the first one is a 0. This next one, all we're going to have is a 1, because we have 0, 0, 0, and then our W is equal to 1. We know that W is equal to 1 just from the fact that this is 16 bits. So W is equal to 1. And we've ever done something like this before previously. So with our W equal to 1, we're going to type in our registers. So we have register 1. Let's just say that this is our A of X for now. If we scroll up here, we can find our A of X. It's going to be right here. It's going to be 0, 0, 0. And this looks familiar. We might have them in the wrong spot, but we'll check that in a second. We have a register 2, and that's going to be equal to, we know this is a D of X, so this is going to be 0, 1, 0. And so those are our registers. So we have, for the binary, our 1, 1, because it's hard-coded, then we have a 0, 0. Then we have our 0, 0, 1, 0. So when we translate this to hex, we should have a 0, 1, and then this is going to be 8 plus 4, so that's 12. And then 12 in hexadecimal is C, so A, B, that's 10, 11, and C should be 12. And this last one here is just going to be a 2. So if we check this right here, we can see how close we got for the add. And for this one, we do have a slight mix-up right here. We can see that this should not be C2 if we look right here. If we do our add, it should be 0, 1, D, 0. So this should be D and 0. So this probably means that we got these mixed up. So we can switch our registers. So we're going to do this one here, and this one should be 0, 0. And if we do this, we can look back here. Nothing should have changed really. We're still adding just like this. We should just note in our notes right here that we're doing register 2 to register 1 that's being added when we write it out. So our register 1 is going to be our D of X. So we can also write this in here. So register 1 is D of X. And then we can just write that our register 2 is going to be our A of X. And so if we do it like this, we know that we are going to have our 1, 1 in here, then we're going to have a 0, 1, and this one is just going to be all zeros. So that means that this is going to be a 0, and this is going to be a D because we're just adding 1 to it. So adding 1 to a C makes it a D, and then we have our 0, 1, D, 0 here. And so that's it for our add AX, DX. For this one, all we need to do is combine all of these into one thing. So we'll take these cells, come in here, and we'll paste it without the spacing. Side note though, if we are to write it like this would kind of be incorrect, because if we look back here, we don't want register 2 to register 1, we want register 1 to register 2. So instead what we can say is that our register 1, the first one that's going to come up, is going to be our D of X. So if we go up here, we can see our D of X again. It's going to be this one, 0, 1, 0. That's the first one. So our register 1 is D of X, and then our register 2 is our A of X. And so that is the correct way to write it. We're going to write the DX first and then our A of X.